Welcome back to P4. Today we're looking at integration by parts, unit 6.4. So I'm going to jump straight in with the integration by parts technique, or how you're going to write and rewrite the function that you're trying to integrate. And here it is. So we get u dv by dx, and that's going to be equal to uv minus the integral of v du by dx. So this is where we get our start. We'll have two terms within there. One we're going to call u and one we're going to call dv by dx. And from these we'll create a du by dx and a v. Now it's quite important which way around that we name these. So within a function, if we get anything where we've got an x to the power in there, like x to the power n, whatever n could be, like x squared, x cubed, and so on, we will always make u equal to that x to the power. There is one exception, and then we'll make the dv by dx the other term. There is one exception, and that is when we're dealing with a log x, so an ln x. In that case, then we'll make u ln x, as it's far easier to differentiate ln x. So that's the one exception there. And I should actually mention, why we do this. So we do this when we have got, a function times a function. So think back to when you did differentiation, product rule. If you remember doing that, when we had a function times a function. Same kind of thing as what we're looking at now is when we're integrating a function times a function. But I guess it's easier to show you with an example. So let's do that now. So here we have our integral, what we're trying to integrate, and we've got x cos x. So these are multiplied together. And what we want to do is we want to call one of them u and one of them dv by dx. So we always use the x term, or the x to the power, because that's what we often get in terms of our u, and then our other term as a dv by dx. Just remembering that one exception I mentioned earlier, which we will get to with an example. So for us to be able to do this, we need the du by dx term, which in this case will be 1, and we need our v term, which if I integrate cos, I will get sine x. Okay, just remembering that you are integrating here. Now, I've mentioned this in other videos, but it's always good to label your original integration, and it's nice to use the letter I. That way then when we come down here, we can just write I equals, and we can jump straight in with what we're trying to do. So in this case it's u times v, and you'll notice that these are diagonally opposite each other here, u times v. So it's going to be x sine x minus, and then I'm integrating v times du by dx, which is just 1. So that is now my new expression, I guess, probably the best word. So all we've got left to do now is this integration, which is quite straightforward, isn't it? Integrating sine is negative cos, so it's going to become a plus cos x, and don't forget my constant there. Let's have a look at another example. Okay, so starting the same as before, this one's going to be my u term, and this one will be my dv by dx term. So u equals x squared, du by dx will equal 2x. Then we got dv by dx equals e to the x, and when I integrate that, it's going to be the same. Now I'll label this I, so that then I can just jump down here without having to rewrite it. So uv is x squared e to the x minus the integration of, and then we've got v times du by dx. So that gives me 2x e to the x dx. Now, in this particular case, and this is one that does appear in quite a few past paper exams, you'll notice that we've got a function times a function again. So what we actually have to do is we have to do this whole process again just for this one. So if I rewrite these two, so this is going to be my u and this one is going to be my dv by dx. So what we've got here is that u is 2x, so du by dx is 2, dv by dx is e to the x, which we know stays the same when we integrate. So now my I has become x squared e to the x, that's still there, minus, and I'm just going to open brackets for where I'm dealing with this integration. So now we've got u times v, which is our new u times our new v. So that's going to give me 2x e to the x minus the integral of v times du by dx. So that's going to be 2e to the x dx. Now, I'll put that in another bracket just so that then we can deal with the signs and sort it out. So if we look here now, we've got x squared e to the x minus 2x e to the x and then plus 2e to the x dx. Now, so I just noticed I wrote x to the power x, what an idiot. So there we are, x squared e to the x minus 2x e to the x plus 2 e to the x plus c. And then we're done. We could factorize out the e to the x, but it doesn't really make much difference in this question. Now, third example here, and what you'll notice is that this time we've got an ln x in here, and this is the exception. So this is the time this ln x needs to be our u, and our x cubed will become dv by dx. And this is essentially the only time you need to do this. So integrating this one gives me x to the power 4 over 4, and differentiating gives me 1 over x for my ln x. And that's why it's important to do it this way around. So let's go ahead now and write our I equals, so that then we can carry on underneath nicely. So u times v, that gives me x to the power 4, I'm going to write it as a quarter, ln x, minus, and then we've got v multiplied by du by dx. So x to the power 4 multiplied by 1 over x is x to the power 3, and of course we still over that 4, which I can take outside if I want to, but I won't bother in this case. So we got a quarter x to the power 4 ln x minus x to the power 4, and we're dividing by our 4, so that's going to give me 16. So I almost put dx there, but it's plus c. And then this is my final answer. Now, the only thing left to show you is what happens with limits. So let's look at this one, and I'm going to add in some limits here. And you can see I've just added in the limits 2 and 1. So what happens is you do your integration as normal here, the integration by parts, and when we get to our first line here, what we want to do is we need to make sure that our u and v are in our limits, and that those limits are also applied to this new integration. Okay, and it's important to do these two separately. Once I've done that, then I can move on to the next line, finish it off. So I'm just going to add in the limits again on here and get rid of this plus c, as obviously we don't need it anymore. So we can see here that we're looking to finish, it's going to be a quarter of 2 to the power 4 ln 2 minus a quarter 1 to the power 4 ln 1, and that's in my first set of brackets, and then I've got 2 to the power 4 over 16 minus 1 to the power 4 over 16 there. So from my first bracket, 2 to the power 4 is 16, a quarter of that is 4 ln 2, and then ln 1 is 0, so that's going to become 0. Then looking at my second bracket, 2 to the power 4 is 16, 16 over 16 is 1, minus 1/16 is 15 over 16. And there we have it. Now, it's always worth leaving these as a exact value, especially when you've got them in terms of logs. And don't forget, you should always use your calculator's numerical method with the original just to check that this does equal the same. Make sure there's no mistakes in your working. Now, hopefully I've covered everything here. I'll do a few questions, and as always, I'll put the answers at the end. Have a go, and as usual, just leave a message in the comments, especially if you have any more questions or you're not sure about something I've done. Just let us know in the comments and I'll reply to you. And if you're new to the channel, don't forget to hit that subscribe button. You may not need all my videos now, but maybe when it comes to exam time, you might. Always worth having it there so it's easy to find. Otherwise, enjoy the rest of the video, and I'll catch you in a later video.